right, today for our math, we are going to be looking at factoring. So we're going to start off by reviewing a few things. Okay. And this is a rather simplified definition of what a factor is. But basically, a factor is a number that when you take it and multiply it by another number, you get a new number. It's the numbers that make up other numbers. So for example, if we take the number 12, well, 12 is 2 times 6. 2 is a factor. 6 is a factor. Those two numbers multiply together to give me a new number. But 12 is also 3 times 4. Well, 3 is a factor. 4 is a factor. If we have x cubed is made up of x times x times x. Each x is a factor. The things you use to multiply together to get new numbers. Okay? Now, I tend to write fast, so if I go too fast, you need to let me know so that I don't move to the next. If I move to the next page and you haven't gotten it, let me know and I'll go back. And for some reason, y'all's homework is starting to come in on the emails. I don't know what in the world. Some of this is from over an hour ago. Yeah, I guess so. All right, so factors. We also need to talk about something called GCF. GCF stands for greatest common factor. And the greatest common factor is the largest, that's why it's called greatest factor that makes up a group of numbers. And when I show you this, you're probably going to say, oh, I remember doing that when I was in school. If I ask, what is the GCF of 12 and 15. The biggest number that goes into those two numbers. Correct, Mr. Seymour. Correct. 3. The way we get that is we factor each of these two things, and we do what is called a prime factorization. 12 is 2 times 6. 2 cannot be broken down any further. It's called prime. 6 is 2 times 3. 2 cannot be broken down any further. 3 cannot be broken down any further. So 12 is really 2 times 2 times 3 if you take the number 12 and break it all the way down into its bare bone numbers that make up that number. In other words, the factors, you can't break them down any further. 15. 15 is 3 times 5. 3 does not factor down any further. 5 does not factor down any further. So 15 is only 3 times 5. Well, the greatest common factor, greatest meaning the largest, and factor in common, the factor that's in 12 that is also in 15 is 3. The GCF is 3. 3 is the largest number that goes into 12 and 15. The largest number that goes into both of those. Okay. If we had 21 and 14, 21 factors into 3 times 7. 21 is 3 times 7. It's not anything else. 14 is 2 times 7. Those don't break down any further. So 14 is 2 times 7. The greatest common factor is 7. And again, when we do this, it's called the prime factorization. And again, I would imagine if you stop and think for a minute, you will remember doing that in school. And I'm sure that your math teacher made you do hundreds of them, probably to the point where you were sick and tired of doing it. Yes, if you got kids, your kids are doing it, depending on what grade they're in. Okay. Now I'm going to do something that's going to look like I've lost my mind. This box has 3 flowers. This box has 2 flowers. This box has 1 flower. Okay. All right. How come I can't take 2 flowers out of every box? Okay. Correct. If there are 3 flowers in the first box and 2 flowers in the second box and only 1 flower in the third box, I can only take 1 flower out of each of those boxes if I'm going to take the same thing out of every box. Okay? Now, in a few minutes, I'm going to be talking about flowers in boxes. And I want you to see the connection. Same question. I have a box that has 5 Y's in it. I have another box that has 3 Y's in it, and another box that has 2. I have to take the same number of Y's out of all 3 boxes. Good. I have a box that has a 2, a 3, a 7, another 2, and a 9. The second box has a 2, a 3, an 11, and a 5. And the third box has a 2, a 3, a 7, and 11. I have to take the same numbers out of all three boxes. Okay, be careful. I'm asking, we have to take the same numbers themselves, not the same number of items. The same numbers have to come out of every box. So in other words, that number has to be in all three boxes. So we can take a 2 out of each box. And we can take a 3 out of each box. Does that make sense? Okay, I'm going to come back to this, and I'm going to say, y'all said this makes sense. So, we need to remember the distributive property. If I have 3 times x plus 1, we take the number on the outside and we distribute it over each number on the inside. That's what we were doing on Tuesday. 3 times x is 3x. 3 times 1 is positive 3. Careful. Not 3x plus 1. Yep, 3x plus 3. 3x plus 3. 3 times x, 3 times 1. Well, y'all are so used to going from this to this. Today, we are going to go from this back to that. Inside of box number 1, there is a 3 and an x. 3 times x. 3 is a factor, x is a factor. Inside box number 2 is a 3, and there's also an understood 1, because 1 is a factor of everything. I have 2 boxes. I have to take the same thing out of both boxes. What will I take out of those boxes if I have to take the same thing out of both boxes. Exactly. If I take a 3 out of those boxes, then the thing that is left is x plus 1. Okay? Oh, yep. I hope all of you are. So I have 4x minus 20. I need to know what can I divide into 4 that I can also divide into 20. What number goes into 4 that will also go into 20? Ooh, some of y'all are not thinking. 5 does not go into 4. So it can't be 5. 5 divide into 4 evenly. So 2 is correct. 2 would work, but a better answer is 4. Yes. This box has 4 times x in it. This box has -5 times 4 in it. Because remember, we're looking for the greatest common factor. Greatest, the biggest number that goes into both of those. If I did 2's, if I said that this was 2 times 2 times x, and this box was -10 times 2, if I take only a 2 out, there's still a 2 inside of this 10. I didn't take enough out. We have to take as much as we can out. Okay? So, the thing that's in both boxes that I can take out is a 4. What's left is x minus 5. If I use distributive property, I should get what I started with. 4 times x is 4x. 4 times -5 is -20. 4x minus 20 factors into 4 times x minus 5. (5m plus 25). I want the biggest number that can go into 5 and has to go into 25 evenly. Exactly right. This box has 5 times m. This box has 5 times 5. I can take a 5 out of both boxes, and when I do, I'm left with m, that's a positive 5, so it's m plus 5. 5 times m is 5m. 5 times 5 is 25. You can check every single problem because you can look to see if I multiply it back out, will I get what I started with? Okay, it looks like some of y'all aren't participating. Need everybody. Okay, so that must mean that this box has 7 times x in it, and this box has 7 times -2. I can take the 7 out of boxes, and I'm left with x minus 2. 7 times x is 7x. 7 times -2 is -14. You do that one. Okay, looks like I need 2 more. Unless I missed somebody. 3 more. So I'm waiting on some answers. Okay, all right. The number that will go into 6 and into 30 is 6. This box has 6 times m. This box has 6 times -5. The 6 gets pulled out of both boxes. We're left with m minus 5. All right. Anybody have any idea what I can take out of both boxes? Very good. I'm so glad to see that. X squared is x times x. This box has 3 times x. I can take an x out of both boxes, and I'm left with x plus 3. X times x is x squared. X times 3 is 3x. Okay, yes. This box has m times m. This box has -2 times m. I can take 1m out of both boxes. I'm left with m times m, which is m squared. I only took one of those m's out, and I did that because I can only, the second box only has one m in it. So if I'm going to take the same thing out of both boxes, I can only take one m out, m to the first out. So the m times m is left over, m squared, and the -2 is left over. M times m squared is m cubed. M squared times -2 is -2m. Okay, you are correct. I can only take an x out of both of those boxes. I have left 3x minus 5. Okay, now I'm going to stop drawing the boxes because you need to be able to see what is happening. Now, I may go back to the boxes in a few minutes when the problems get a little bit more complicated, but right now, I'm going to stop writing the boxes. Let's look at y'all got used to this to all the other problems. If I draw the boxes, this is 4 times A times A times A times A. This is -7 times A times A. I have to take the most. I have to take the most. Can't leave anything behind. Okay. Now, for new folks, to write an exponent, if I'm going to write x to the fifth on your keyboard, you do x. Then there's an up caret key above your 6. So if you do shift 6, so it will look like x up caret 5 on your keyboard. So you're right. I can take an A and another A, and A and another A. That's not 2A. It's A squared, because remember, these are all being multiplied, and A times A is not 2A. A times A does not equal 2A. A plus A is 2A. A times A is A squared. So I can take two of these A's out, which is an A squared. I'm left with 4 times A times A. That's 4A squared. And over here, all of the A's are gone. I'm left with minus 7. A squared times 4A squared is 4A to the fourth. A squared times negative 7 is negative 7A squared. Okay? Yes. This y to the fifth that you got to, again, let's start visualizing it in our head so we don't have to draw those boxes every time. There are 5 y's being multiplied together in that first box. And there are 3 y's being multiplied together in the second box. So I should be able to pull 3 y's being multiplied together out of both of those boxes. So what comes out is y cubed, because there are 5 of them here, there are 3 of them here. If I have to take the same amount out of both, I can only take 3. Y times y times y. I'm left with 6. I took 3 of these, so there are 2 left being multiplied. And then I took all 3 of those y's out. I'm left with negative 5. Y cubed times 6y squared is 6y to the fifth. Y cubed times negative 5 is negative 5y cubed. All right. Now I'm going to throw a little monkey wrench into it. Nine x cubed. This box has in it 3 times 3 to make up the 9. And the x cubed is x times x times x. This box has a 3 because it's got to be the same, but I need a negative, so that means I'm multiplying by -1, and then I have 2 x's being multiplied together. Because this stuff, when it multiplies together, it's got to give you this back. So that's why I had to put the -1 in there, was because I need a negative 3x squared. 3 times -1 times x is negative 3x squared. So I can take out 3 out of both boxes because 3 goes into 9 and 3 goes into -3. And I have 3 x's being multiplied together here. I have 2 x's being multiplied together there. I can take out both of those, and I'm left with 3x minus 1. And I can check it. 3x squared times 3x is 9x cubed. 3 times 3 is 9. X squared times x. 2 x's multiplied together. Another x being multiplied together is 3 x's being multiplied together. 3x squared times -1 is 3 times -1 is -3. 2 x's being multiplied together and no other x's being multiplied together. I have 2 x's being multiplied together. This box has 2 times y times y times y. This box, if I could get a 2 out of that, that would help. So yes, there's a 2 in that -4. It's 2 times -2 times a y. So I need to look at what is in both of those boxes that I can pull out. I can pull a 2 out, and there is only one y in this box, so I can only take one of those out. So we're taking out 2y. We're left with y squared, y times y, minus 2. 2y times y squared is 2y cubed. Y times y squared is y cubed. 2y times -2 is -4y. Fifteen. We're with 15, we know there's only 3 times 5. So that's 3 times 5. Y to the 4th. Y times y times y times y. Positive 9. 3 times 3 times y times y times y. What am I going to take out of both boxes? Okay. Y'all told me you understood having the boxes and taking the same thing out of both boxes. And yet, you're not, some of you are, but some of you are not taking the same thing out of both boxes and taking the most. You got to take everything you can possibly take. You can't leave anything behind that could be in both boxes. So some of y'all are saying y cubed. Well, that's not right. That's part of it because there's three y's here and there are three y's here. But I got a 3 and a 5. I got a 3 and a 3. There's a 3 in both of these. That 3 has got to come out. I have 1, 2, 3, 4 y's. I have 1, 2, 3. That means I can only divide out 3 of those y's. So y cubed comes out. So 3y cubed is what comes out. Because there is a 3 in both boxes, there is a y cubed in both boxes. The stuff that's left and because that's a positive 3, it's plus 3. 3y cubed times 5y is 15y to the fourth. 3y cubed times 3 is 9y to the third. Oh, whew, wait a minute. Now I have 3 boxes. Box number 1 has 2 times 4 times x times x. This box has 2 times 2 times x. This box has 2 times negative 1 because I need the same number. The only thing that can come out of each of those 3 boxes, because it has to be the same thing out of all 3 boxes, right, 2. If I take a 2 out, divide that 2 out, I'm left with 4x squared. If I take this 2 and divide it out, I'm left with 2 times x. If I take this 2 and divide it out, I'm left with negative 1. 2 times 4x squared plus 2x minus 1 is 8x squared plus 4x. 2 times negative 1, negative 2. You can check every single problem. 9m squared. 9 is 3 times 3 times m times m. 12. I'm not going to write 2 times 6. Why would I not choose 2 times 6? Okay, right. I'm trying to get numbers that are the same. And I already know I don't have any 2's in here. So why choose 2 when that isn't going to work? That ain't going to help me. I need to choose numbers that are going to help me. I know that 12 is 3 times 4. Okay, I got a 3 in both of those boxes. Maybe there's a 3 in that last box. It's 3 times 4 times m. This box is 3 times 5. The 3 divides out. I'm left with 3m squared plus 4m plus 5. Fifteen is 5 times 3. D cubed is d times d times d. 20, I'm not going to choose 2 times 10 because 2 times 10 doesn't help me. I'm going to choose 5 times 4 times d times d. And negative 5 is 5 times negative 1. The 5's divide out of can come out of every box. I'm left with 3d cubed plus 4d squared minus 1. 5 times 3d cubed is 15d cubed. 5 times 4d squared is 20d squared. 5 times negative 1 is negative 5. Hey.
Good night. My email's not working, so I'm not.
Mine's not either.
Okay, good. I'm glad someone else can vouch.
All right. Okay. Yes. And I'm getting some in now that were sent over an hour ago.
Yeah, I can't open any document. Nothing. Okay.
There was something weird going on this morning too.
Yeah.
I couldn't quite put my finger on it.
Yep.
But I didn't have any problems with the email this morning.
Mine was Gayless.
It was Blackboard. Blackboard.
Oh.
It would spin and spin and spin and spin and spin.
Gayless is doing the same thing for me and Mary because she called me to ask if I was so something's going on.
I'm glad that I'm not crazy.
Yeah. If I don't see you tomorrow, have a good weekend. Y'all stay safe.
Yes, y'all too.
Let me know
y'all
if you need anything.
Okay. Thank you. Appreciate it.
Bye.
Bye-bye. All right, let's see. Ooh. Visualize those boxes. visualize those boxes. The only thing that's in all three of those boxes is an X. What's left? It would be -2. But there's still an X in there because there were two X's. This second box has -2 and two X's being multiplied. And we're taking an X out of all three of the boxes. So I want to know what's the rest of the inside of the parentheses. Right? Okay. So for number 4, we have a to the 5th minus a cubed plus 5a squared. What can I take out of all three boxes? Five flowers in this box, 3 flowers in this box, 2 flowers in this box. I have to take the same number of flowers out of each box. It's not 1, it's 2. And it's not 2a, it's a squared. This box has a times a times a times a times a. This box has -1 times a times a times a. This box has 5 times a times a. 5 flowers, 3 flowers, 2 flowers. I can pull 2 flowers out of each box. Y'all are making this way too hard. Some of y'all are getting it. That's good. You're catching on. But don't make it too hard. Don't make it hard. Some of y'all are making this way too hard. All right, what about this? And that's an 8. What can I take out of both boxes? Ooh, some of y'all are changing your mind. If I just take 2, if I do this as 2 times 2, I'm still left with this 4 that has a 2 in it. So I've got to recognize that 8 is 2 times 4, and there's a 4 over here. There's a 4 in both of those. So what's coming out is 4x. 4x. We're left with 2x squared minus 1. It was 4 times negative 1. Oh, and 4. And 3. You're right. I should have written that as, but the reason I didn't write this as 4 times negative 1 is because by the time I got to this box, I realized there was no number part that was going to come out of each box. You really realized it here because there was no number part to the first box. So it doesn't matter if I factor down the second box or the third box because there isn't a number that's going to come out of those. Does that make sense? So I could have called this 2 times negative 1. But because I wasn't pulling something out of all 3 of those boxes that was a number, there was no need in breaking it down. All right, I want you to do this one and tell me what your answer is. Do the whole thing, all the way through. One more. One of you didn't answer. All right, let's see. 9, that's 3 times 3. M cubed is M times M times M. This is 3 times 5 times M times M. Very good. Now, let's see. Whoa. What's going to come out of all 3 boxes? That's the first thing I'm going to ask you. What comes out of all 3 boxes? Yeah, some of y'all are answering too quickly and you're not taking your time looking carefully. 2D. 2D is the only thing that can come out of each box. I can't take D cubed because there aren't 3 D's in the third box. 4 flowers, 3 flowers, 1 flower. I can only pull 1 flower out of each box if I'm going to pull the same amount of flowers out of each box. Then 4D cubed is what's left in this box, minus 2D squared is what's left in that box, and in the last box, 3. Got to think about those variables as being flowers. Numbers, you got to think about, okay. Yes, that's a cubed, I'm sorry. You've got to think about what number goes into 12 and 15 and into 3. Okay, so I can take more than just 3 out because each box has flowers. I can take a 3 out of every box, and I can take a flower out of every box. So this is 3m times, if I take a 3 and an m out of every box, there's 4m to the 4th minus 5m squared plus 3. Okay, now look what I'm going to do to you next. The problem does not change. You still have to take the same thing out of all 4 boxes. You have to take the same thing out of all 4 boxes. So again, don't try to be the first one to answer. Look carefully at the problem. because the first box got 7 flowers. The second box has 4 flowers. The third box has 3 flowers. The last box has 2 flowers. I can take more than 1 flower out of every box. I can take 2 flowers out of every box. This box, I'm looking at 20, 10, 5, 15. I noticed something about 20, 10, 15, and 5. 5 goes into all 3 of those. So that's going to be my number that I want to focus on. So 20 is 5 times 4. And then I have 1, 2, 3, 4, 5, 6, 7. Then here, 5 times negative 2 to give me my negative 10 times x times x times x times x. 15 is 5 times 3 times x times x times x. This is 5 times negative 1 because I'm going to take that 5 out. So there's got to be something else there. Times x times x. 5 can come out of every box. X and another X. I'm left with 4. 1, 2, 3, 4, 5. X to the 5th. 2 from 7 is 5. Minus 2x squared plus 3x minus 1. This is not hard. Okay, about number 8. All right, let's go back to number 8. You know what? I bet I know what you're going to ask me. I see what I did. Again, if I can make the mistake, then y'all can make the mistake too. What this should show you is that if you go too fast, you're going to make mistakes. And I am just as guilty of it. This should be 1. So there should be a 1 there because we took the 3's out and we took an M out. So there's got to be something left in the box. That something is a 1. So thank you for catching that. Good eye. Good eye. Again, you catch me making a mistake, you tell me. It's easy to do. So you've got to take your time and you have to think about what you are doing. Okay? Because it is so easy to make a mistake. The reason there has to be something left in the box is because I have to be able to get this term right here. I have to be able to distribute the 3m here, here, and here so that I get this last term. If that was just 3m times 4m to the 4th minus 5m squared, if I distribute this, I don't get a 3m at the end. Okay? So the box has to have something left over in it. Every box. if you end up pulling what looks like everything out of it, there's always a 1, because I can put 1 in every single one of these boxes. I can put as many 1s as I want. I can put 50 1s in there if I want to, because I haven't changed the value. It's still 1. But there's got to be something left in the box. Okay, wow, time has flown. I'm going to give you one more because you're going to see this. So give me a second. It's not complicated. It's not complicated. It's just I got different kinds of flowers. Roses and daisies and peonies. This box, whoops, has in it, let's see, let's look at the numbers first. 8, 4, 12. What goes into 8 that also goes into 4 that also goes into 12? That would be 4. So 8 is 4 times 2. Then I have x times x times x. I have y times y times y times y. And I have z times z. I have 4 times 1, because I'm going to take that 4 out. Got to be something left there. And I've got x times x. I got y times y times y. And I have z times z. 4 times. Well, to get negative 12, I have to have a negative 3. X times x times x times x times y times y times z. 4, 4, 4. 4 can divide out. Let's look at the x's. 3 of them, 2 of them, 4 of them. 3 flowers, 2 flowers, 4 flowers. Or let's say 3 roses, 2 roses, and 4 roses. I can only take 2 roses out of each box. 4 daisies, 3 daisies, 2 daisies. 4 daisies, 3 daisies, 2 daisies. I can only take 2 daisies out of every box. Peonies, peonies, 2 of them, 2 of them, 1 of them. I can only take 1 peonies out of each box. I'm left with 2 x y squared z. 2x y squared z plus the 1, which I don't have to write, but I can if I want to, y z minus 3x squared, and that's it. It's not any different. You have to look at what is in each box. You have to be able to take the same thing out of every box. You have to make sure that you take the most out of every box. You can't leave stuff in boxes that could have come out of every box. So that's why I didn't do 4 times 2 and 2 times 2 and 2 times 6, because if I only took the 2's out, there's still a 2 inside of that 4, there's a 2, and there's a 2 inside of that 6. I strategically chose 4 because I looked at 8, 4, 12 and realized, 4 is a factor inside of each one of those 3 numbers. That is what comes out. You have to practice this.
This has been a production of D&J Designs and Mathman 1962. If you like this video, click on the thumbs up. If you want to be notified when new videos are posted, click the bell. And if you want to see more videos like this one, click on the subscribe button.